Welcome to Spring LIB.
Okay, so this question is a very typical question for the chemical reaction stoichiometry. So it's a reaction of combustion. It says it's acetylene react with oxygen and produce carbon dioxide and water. So first we need to balance the equilibrium. Already tells you we have the acetylene reacts with oxygen, and then it will forms carbon dioxide and water. So the easiest way to balance the equilibrium is just simply look at carbon and hydrogen, since they are in the same molecules. So we can first fix the C2H2 as 1, and we know we'll definitely produce 2 carbon dioxide because there are 2 carbons here. And then we'll produce 1 water molecule because there are 2 hydrogen in the acetylene. And now we can calculate or just count how many oxygens, right, in the reaction. So in the product sides, there are 2 times 2 and plus 1, there are 5 oxygen atoms. So here, the oxygen should be 5 halves, right? Because you have to make sure all the elements have the same number. And now it's actually balanced. So it says you have 10 grams of the acetylene. What you need to do is first to calculate the moles of the acetylene used. So it's equals to the mass over the mole mass. The mass here is 10 grams. Mole mass for the acetylene is 2 times 12 plus 2, so it's 26. So now we can calculate it. Which is around 0.3846 more. So this is a more of the C2H2. And from the chemical equation, you'll find and then reacts with 10 grams of the oxygen. So the moles of the oxygen here will simply same the mass over the mole mass. So 10 grams over here is 32 grams per mole. So you know from here it's actually equals to around 0.3125 more. So they react. These two react. And the second part all we need to do is who is rebondant, which is a limit agent. So as you can see, every time you consume, let's say for a complete reaction, from the chemical equation, you can see every time you consume 1 moles of C2H2, you are consuming 2.5 moles of the oxygen, which means the number of the oxygen should be 2.5 moles of the C2H2. And you can say, but in the given situation, the given amount of the reactant, the ratio of the C2H2 and O2 is nearly 1-to-1 ratio. So in this case, the oxygen should be the limiting reagent. And this is actually redundant, which means the production of CO2 and water will be determined by the amount of the oxygen that is used in this case. So now we can see every time, also just from the formula chemical equation, you can see every time you consume 2 moles of the carbon dioxide, you produce 2 moles of carbon dioxide, you are consuming 2.5 moles of oxygen. So then we know that the moles of the carbon dioxide, which is simply equals to 5/4 moles of the it's actually equals to here every time you consume. So here 5/2 moles of the carbon dioxide simply equals to 2 moles of the oxygen here. So now we know the moles of the carbon dioxide are simply equals to 4/5 moles of the oxygen. And it's equal to 4/5 times this used oxygen, 0.3125. And this equals to around 0.25 moles. So which means here the mass of the carbon dioxide simply equals to the moles times mole mass, which is this times 44, which equals to 11 grams. And then same in the reaction, every time you consume 2.5 moles oxygen, you are producing only 1 moles of the water, which means the moles of the water is only 2/5 moles carbon dioxide. So it produces equals to 0.125 moles. And the mass of the oxygen here, the mass of the water here, just water, or simply equals to here is just oxygen. Water here simply equals to the mole mass times moles. So the mole mass of the water 18 times 0.125 equals to around 2.25 grams. And now, as we said, the C2H2 is redundant, so we can calculate how many C2H2 was reacted. So it's reacted. So it's actually equals to, if you look at the formula, you find every time you consume 1 more, you are consuming 2.5. So equals to 2/5 moles of the oxygen that you consumed. So here it's the same, equals to 0.125 moles. So now it's reacted, which is consumed, right? The mass of the reacted one is equals to mole moles times mole mass. So it's 0.125 times 26, which equals to around 3.25 grams. So the mass, C2H2 left, which is simply equals to the total mass, 10 grams, minus the reacted one, 3.25 grams, which equals to 6.7 grams. So the answer is, how many grams of C2H2 left is 6.75. How many grams of oxygen left? It's actually 0, since it's a limiting chemical reagent. And then you know how many moles, how many grams of the water left. It's 2.25 grams. And how many grams of carbon dioxide left? That's 11 grams. And this is the answer.